jump into it. So today we want to focus on factorizing. So factorizing, let's have a look at the first type of factorizing, where I'm going to factorize an expression with a constant factor. Okay, so let's go to example number one. Let's suppose I've got 16a plus 8. The first thing I'm going to do is I see, okay, well, 16 is 8 times 2a, and I can then factorize out 8 by removing it and writing whatever's left inside a bracket. And once I've removed something completely, I replace it with 1. All right, so let's go through it one more time, right? I've got 16a plus 8. I can see that 16 is 8 times 2, so I take out 8 as a common factor, and I'm left with 2, because 8 times 2 goes back to 16, and 8 times 1 gets you 8. I can't factorize it any further, and I'm now done. All right, factorizing, remember, it's about creating brackets by removing common factors. All right, creating brackets by removing common factors, or what can divide into terms. All right, creating that. Okay, now you try this one, all right, before we move on to the next one. You try, let's suppose you have 45c plus 50. Try and factorize that. I'm going to press pause and wait. Okay, so the first thing I got to do is look for a common factor between 45 and 50. And remember, it's also the highest common factor. So I can see that this is 5 divisible by 5 times 9. And I can see this is 5 times 10. So I can see that 5 is definitely one of the common factors. Is it the highest common factor? Let's take it out. Let's take out 5 from 45, we're left with 9. Let's take out 5 from 50, we're left with 10. There's no number that is common between 9 and 10. So that's my final answer over there. Yes. Now, in the second example, we're going to be factorizing an expression, but this time we have a variable that is a factor. Okay, so example number 2, if I got a variable as a factor, let's suppose I have 7d cubed plus 8d plus 2d squared. In this example here, I can see that each term can divide by d. Not d squared, not d cubed, but definitely d, because the middle term will end up as 8. The term in front will end up as 7d squared. And the term on the far right will end up as 2d. And I take out d as a common factor outside. All right, we can see in this example, I took out d as a common factor. What can you divide everything by? Take that out, put it in front. Okay, all right, you try this one. Let's suppose I've got 5a plus 6a cubed. Try that one there, see if you can do that. The common factor over here is a. I can see a can divide into both a and a cubed. Nothing can divide into 5 and 6. All right, there's no number that can divide into 5 and 6 because there's no common factor, right? So this is going to be 5 plus 6a squared. All right. All right, and that's the answer. Okay. So in the next example, what we want to do is we want to factorize an expression that takes out both a constant and a variable factor. Okay, we want to take out a constant and a variable factor in one. Let's suppose I've got 12 xy plus 144 x. The first thing I look at is the numbers. And I say, okay, well, what number can divide into 12 and 144, and what's the highest number? Now, 144 is 12 times 12. So I can definitely take out 12 out of 12 and 144. Then I look at the variables. x and y and x. What's the highest letter, or what's the most letters that I can take out, or highest power in this case? We don't have to worry about that. I can take out
The
just x, yeah. So we take out x. And now we just write down whatever's left behind. And if there's nothing left behind, we replace it with 1. So I would put y over here plus 144. All right, you try this one over here. Let's suppose you got 100 xy minus 25y. Press pause, and when you're ready, press play. So we got a highest common factor is 25, and we take out the y because that's the common letter. 25 times 4 is 100, times 4x gets me 100xy. 25y multiplied by 1 gets me the last part over there. Okay, well done. In example number 4, what we're going to be given is 4 terms, and we are going to factorize the terms separately in parts. All right, this is by grouping. So example number 4 is factorization by grouping, where you're given 4 parts. So let's suppose I've got 3a plus ab plus 5w plus 4wy. The first thing I look at is the first 2 terms, and I put a bracket around it and take out what's common. So that's a. Factorize a, write whatever's left. I then look at the second 2 terms, and in this one here I take out w, and I'm left with 5 plus 4y. All right, let's look at example 4b. In the situation where I'm given a very similar kind of question, but instead of positive, I've got a negative 5w. When I group the first 2 terms, I still factorize it out. Now I'm left with 3 plus b. When I group the second 2 terms, the one thing I have to remember is by putting a bracket around the second 2 terms, I have to change the sign into the opposite sign, which is negative, right? That means if I take out negative w, I'll be left with 5 minus 4y, because minus times a minus will have to go back to a plus. This is the one which doesn't have a common bracket. There's no common bracket here, but in the next one you'll be able to see a common bracket. Okay, so try this example here now. bf plus 2bg minus 2p minus 3pq. So, all right. So now that you've tried it, let's put a bracket over here and take out a common factor, which is b. Then we put a bracket over here, but because it's a negative in front, we have to change this to the opposite sign. And the opposite sign is plus. So by taking out b now, I'll be left with f, because b times f is bf, and 2g. Taking out the negative, I'm now left with 2p, which I can take out a common factor. Let's take out the common factor in one go. So I take out p, and I'll be left with 2 plus, and 3, and q is remaining. So write that in the second bracket. So when I multiply it back in, I get there. All right, cool. Well done. Awesome. All right, so example number 5, we're going to be finding factorizing, but a common bracket where we're going to end up with the product of 2 brackets. All right, so a simple example like this would be, let's say I've got 5a plus 5b plus ac plus bc. Okay, example number 5. I take out a common factor of 5, and I'm left with a plus b. In the second 2 terms, so I group those 2 together, and I take out a common factor of c, and I'm left with a plus b. And immediately I can see there is a common bracket. Now, if you treat the common bracket as a variable, like let's say 5k plus ck, you can take out k and you'll be left with 5 plus c, where k is the bracket, which means that that can become a plus b, 5 plus c. Okay, and if you can go straight from there to there, that's also fine. So this is using the k method. If I let k equal to a plus b, the common bracket, then that becomes k. And then k obviously takes that on. Okay, now try this one. Suppose you have AC plus BC plus AD plus BD. Okay, so we're going to group the first two terms, and I can see a common C. So I write whatever's left, A plus B. I group the second two terms, I see a common D. And I write whatever's left. They happen to be common brackets, so I then take that out. You're most likely to get a question like this in a test, not like the previous example of 4s. That was just to help you to do this. All right, and that's your final answer there. You can see the common bracket just goes in front, and whatever's left goes in the second bracket without the K method in this case. Okay. Example number 6 is known as difference of two squares factorization. Okay, so example number 6 is known as a difference of two squares factorization. Example number 6, I'm just going to write here difference of two squares. So let's say I give you a simple term like a squared minus b squared. When we factorize a difference of two squares, difference means minus and two squares means a squared and b squared. So a difference of two squared, we put two brackets and we write the first term, we find the square root of the first term, and that will be a. We write it twice. Then we find the square root of the second term, and we write that twice as well. And then we put plus and minus, making sure that the signs have to be opposite each other. And that's how we would remember this. But now when I multiply it out, I can check. I can do a quick check, just a quick check to see if it's right. So a times a gets me a squared. A times minus b gets me minus ab. B times a gets me plus ab. And b times minus b gets me minus b squared. And because of the plus and minus, the middle two terms end up canceling each other out completely. So that leaves me with a squared minus b squared, which is the question. So that's right. Okay, now let's do a little bit more of a difficult one. Okay, let's say we're going to go into the next one. The next one is, let's say I got 49 m squared minus 100 n squared. Again, the same thing applies. Put two brackets in. Square root the first. Now this is 7m times 7m. And this is 10n times 10n. So I can write 7m over here, 7m over here, and 10n over here, and 10n over here. I put a plus here, and I put a minus here. All right, then I can't go any further than that. So it's going to be 7m plus 10n, 7m minus 10n. And I can't factorize it any further than that. So that's my final answer there. Okay, so you try this one now. Let's suppose you got 25 x squared minus 36y squared. All right, let's go through this one. So we open up two brackets. We write down 5 and 5 because that's the square root of 25, and x and x because that's the square root of x squared. Then we write down 6 and 6 because that's the square root of 36, and then y and y, that's the square root of y squared. Plus over here, minus over here, and that's the final answer there. 5x plus 6y, 5x minus 6y. The next one is factorizing a quadratic. Okay, so the next one is factorizing a quadratic. And in this case, we only got one factor. Okay, so one factor. Let's suppose I've got x squared minus 11x plus 30. When I factorize something like this, I look at the last term. All right, so the starting point, the first thing I do is I find factors that multiply to get the last term, which is 30, right? Positive 30. And those factors are, for example, 1 times 30, 2 times 15, 3 times 10, 5 times 6, and it's the factors. Once you've done that, you then each factor pair, check each factor pair to see if they add or subtract. They can also subtract to get the middle term, which is negative 11, right? Okay, so at the moment I can see that I need to get to negative 11, and I can see 5 and 6 is the closest that will get to 11 because it's going to be 5 plus 6 is 11. So if I want to get to negative 11, I need a negative and a negative. So when I create the brackets here, because I've got a plus term at the end and a minus term over here, that means I have to have two minus terms because the two minus terms will multiply to get the last term, which will become positive. And just as well, if it's minus 5 and minus 6, minus 5 minus 6 is minus 11. So if I have x here, minus 5, minus 6, I can see that the first term is going to be x squared. The middle term is going to be negative 5. The outer term is going to be negative 6. So minus 5 minus 6 will get me negative 11. And minus 5 times minus 6 gets me negative 30. I mean positive 30 because minus times a minus is a plus. And so that's my final answer. All right, try this one now. You get x squared plus 8x plus 15. Try and factorize this one. All right, so for this one, I can see 15 is 5 times 3 and 8 is 5 plus 3. So 5 and 3 are my special numbers. So I put 5 over here, 3 over here, I put x over here and x over here, and I provide a plus and a plus on either side. I get x plus 5 multiplied by x plus 3, and then I'm done. So example number 8, we're going to factorize a quadratic where the squared term coefficient is not 1, where the coefficient in front of the x squared term is not 1 anymore. In other words, if I have something like 6x squared plus 23y plus 20, I can see that this term over here is not 1 any longer. Okay, so in this one here, what we have to do is we got to find factors of both the 6 and the 20 that will somehow add and subtract to get the middle term 23. When I say factors, they multiply. So 1 times 6, 2 times 3. 1 times 20, 2 times 10, 4 times 5. All right, so if I got those as my factors, I've got to choose either or, and this may be trial and error, okay? Or you can draw crosses and do some tests. So I'm going to draw 3 crosses and do some tests. So I'm going to grab from the left-hand side, I'm going to grab the 1 and 6 first, and then I'm going to grab the 2 and 10, okay? And I'm going to place it in there. So I put the 2 and 10 at the bottom, 1 and 6 at the top, and now I'm going to cross multiply. I'll get 10, and 6 times 2 is 12. Then I look at those two terms. Can they get to 23? We need to get to 23. If we add them, we get to 22. If we subtract them, we get to 2 or negative 2. So definitely not those. All right, I'm going to go and maybe keep the 1 and 6 and try 4 and 5 now. So 4 and 5, 6 times 4 is 24, 1 times 5 is 5, and I can already see this is going to get me 29 or 21, not 23. So maybe 1 and 6 isn't working. Maybe I need to choose another vector. Maybe I should choose 2 and 3. So if I take 2 and 3, and let's say 4 and 5, and I put 2, 3 over here, 4, 5 over here, and I cross multiply, this one here gets me 12, this one here gets me 10. When I add it up, I get 22. When I subtract it, I get 2, so it's not going to work. Now, the one thing you can do is you can swap the numbers around. You can swap these two numbers around. Okay, you can swap those two numbers around. And you can swap those two numbers around and retest it. Okay, so you could retest it with it the other way around. And you got to do this quite fast. And once you practice, you'll eventually be able to maybe intuitively pick it up. So the next one, you go 1, 6. Let's say I put 10 and 2. Immediately I can see that's going to be way too high. 60 is so far from 23. Definitely not going to work, right? Then if I go 1, 6 and 5, 4, not 4, 5 now, I get 30 and I get 4, 30 because I multiplied 6 and 5. 1 times 4 is 4. And I get 26 if I minus it and 34. But all my signs are plus, so I definitely have to add it to 23. So that one's out. And in this one here, 5 and 4, this will get me 2 times 4 is 8, and 3 times 5 is 15. And what is 15 plus? I think we hit the jackpot. That is it. 15 plus 8 gets me 23. So those factors are quite important. So let's highlight those factors. Okay, so these factors are highly important. These are the factors I'm going to use carefully in my bracket now, in my answer, my final answer, right? So I've done all the hard work now. It's pretty much done. All I got to do now is just remember, okay, so I took 2 and 3. So let's put the 2 over here. And we put the 3 over here. That gives me 6, just to double check. And I got 5 and 4, all right, from here. But I put the 5 over here and the 4 over here. Because when I multiply the outer two terms, I get 8. And the inner two terms, I get 15. And 15 plus 8 gets me 23. So I definitely got it in the right position, because if I had it the other way, if this was 4 and it was 5, it would be in the wrong position. Everything is plus, and don't forget the variables. So x over here and x over here. And I'm now done factorizing this one. Okay, try this one here. We've got 3x squared plus 20x plus 20x plus 25. 3x squared plus 20x plus 25. Let's go through it now. So over here, I can see now 3 is quite a nice number to start off with because it's a prime number. So there is only one factor, 3x and x. So I know that when I draw this up, I got 3 and 1. That's definitely a factor there. Now 25 is 5 times 5, or 1 times 25. So it's also nice because there's not many factors. So I put 5 and 5 here. 3 times 5 gets me 15. And 1 times 5 gets me 5, and 5 plus 15 gets me 20. So I know 5 and 5 is the factor I'm going to place over there and over there. So I put plus 5 there, plus 5 over there, and just test it. Outer terms, inner terms. 15 and 5 is 20. So that's perfect. That's my final answer. 3x plus 5 and x plus 5 in a bracket.